time during my last lectures in school, I was just wondering about what must my mother have cooked for lunch. When will I get dispersed and ride on a bike aiming to reach my home at the earliest? But this might have never been possible without hydrocarbons. So yes guys, this is my topic. This is the agenda of my video wherein I'm going to explain the term hydrocarbon, its classification, structure with formulas. Before knowing about what is hydrocarbon, we must know that it belongs to a part of organic chemistry. Organic chemistry is a branch of chemistry wherein we study about hydrocarbons and its derivatives. Hydrocarbon is considered as the simplest class of organic molecules. As the term suggests, they are made up of compounds containing hydrogen and carbon, and sometimes they may also contain elements like sulfur, oxygen, nitrogen. Well, through my introduction, you must have known how important hydrocarbon is. And I believe purpose is the greatest motivator, without which we will even not generate interest towards this topic. So the functions are as follows. Most importantly, it is used as a fuel, without which we can't even imagine traveling from one place to other. Second, it is used in natural gas, without which cooking isn't possible. In earlier days, we used to use coal. Even that is composed of hydrocarbons. Apart from that, it is used in manufacturing of dyes, drugs and polymers, and it acts as a raw material for synthetic fibers, solvents, plastics and resins. This is the classification of hydrocarbons. They are broadly classified into two groups, that is acyclic and cyclic hydrocarbons. Cyclic hydrocarbons. As the term suggests, cyclic means in a cycle. The compounds which form a ring of carbon atoms are known as cyclic hydrocarbons. So, for example, pyridine and cyclopentane. Acyclic. A means not, and cyclic in a cycle. They do not form cycle of chains. They, instead of dividing them into saturated and unsaturated, we can also classify them into straight or branch chain hydrocarbon. Example of straight chain hydrocarbon is N-butane, and for branch chain hydrocarbon is isobutane. N represents straight chain, but represents 4, and A means single covalent bond. In isobutane, iso represents branch chain, and but represents 4, and N represents single covalent bond present between the carbon atoms. Now we will discuss about its types. It is divided into two categories, that is saturated and unsaturated hydrocarbons. Saturated hydrocarbons contains at least one carbon-carbon single covalent bond. They are also known as alkanes. Alkanes are also known as paraffins. Now why paraffin? Because carbon atoms have their valencies fully satisfied. Their general formula is CnH2n plus 2. Now let us verify the formula. For example, if we take propane, N is the number of carbon atoms present. C3H2 into 3 plus 2, which is C3H8. Now we move forward towards unsaturated hydrocarbons. In this, the valencies of carbon atoms aren't fully utilized, and they contain carbon-carbon multiple bonds. They are divided into two, that is alkenes and alkynes. Alkenes have at least one carbon-carbon double covalent bond. Alkyne have one carbon-carbon triple covalent bond. Now why alkenes are also known as olefins? Because first member of alkene family reacts with halogen to form oily products. And their general formula is CnH2n, and for alkyne the general formula is CnHn or CnH2n-2. Now here's a note, and we begin with cyclic hydrocarbon. That cyclic hydrocarbon contains 2 hydrogen atoms less compared to the corresponding acyclic hydrocarbon. For example, propane and cyclopropane. Propane is an acyclic hydrocarbon in which hydrogen are 8, but in cyclopropane the hydrogen atoms are 6. Heterocyclic and homocyclic, they are further divided into them, and heterocyclic compounds are cyclic compounds which form ring of carbon atoms including other elements like sulfur, oxygen, nitrogen. Whereas homo means same. They are composed of rings made up of only carbon atoms. For example, benzene and furane. This both homocyclic and heterocyclic are divided into two, that is aromatic and alicyclic compounds. Aromatic compounds in earlier days, they had they had fragrance. That's why they were considered as aromatic compounds. But nowadays, it is defined as they contain a benzene ring as part of their structure. Whereas alicyclic compounds, they do not contain benzene ring as part of their structure. Now, how will we identify whether this component is having benzene ring or not? Whenever there is presence of benzene ring, you will always find conjugation between single and double bonds between the carbon atoms. For example, benzene, we can see here single bond and then double bond, and this series continues. So hereby my presentation ends. Thank you everyone, have a nice day.